Hello everybody, my name is Richard Mitchell. I'm part of the mechanical product management team and work in the US at ANSYS headquarters. I'm actually from this area originally, and I studied at Sheffield Hallam University, which is just down the road from here. So I can echo the comments earlier about Sheffield being a great city for engineering, and the universities here as well. I'm a strong believer that this is a strong city for that. I was lucky that when I studied mechanical engineering at Hallam, my course was actually computer-aided engineering and mechanical engineering, so that has kind of served me well for my career now at ANSYS, having some experience of simulation all that time ago when I started there. So I only have 10 minutes today, so I'm going to get going. So title of presentation, Moving in the Fast Lane with ANSYS Motion. Basically, it's simulation of multi-body dynamics, or MBD. Simulation, as you know, has been around for quite a while, well over 50 years, and in the course of those 50 years it's changed dramatically, starting from simple models like stick models, which we used to model aircraft back in the 1950s and 60s, aircraft that are still being produced and still flying today, models that were built using punch cards. I'm sure some of you probably don't really know what punch cards are, and then even CAD not being around at that time. The models that were built in 3D were built by hand, which wasn't an awful lot of fun. When I started doing simulation, it wasn't stick models in the 1950s. It was, I think everybody who started doing basics in simulation started out with something like this, a hole in a plate model. Basically, plate model, pull each side and see the stresses, except it wasn't even a whole plate. It was just a quarter of a plate, because that was more efficient to run. So you use some symmetry conditions there to get a quick model carried out. So these are all static models. The static models are incredibly useful. They're used for pretty much everything you can think of: the chairs you sat on, the phone you carry, the cars you drive. They're used day to day by our customers and users of simulation software everywhere around the world. But again, what I want to talk to you today about is dynamic analysis. And most systems or most products and parts have some kind of dynamic component or behavior to them. An example here is this tower crane. So there's two load cases here. The one on the top is with the crane just stationary with a load hanging off it, and you can see where the maximum stress is. It's kind of above where that load is suspended from. It's kind of fairly obvious, you'd expect to see that. When the crane moves around, though, in this dynamic case, we actually see quite a lot of stress and potential fatigue build up around the base of the tower there as the moment acts on that tall tower going on there. So, introducing, ANSYS Motion. What is ANSYS Motion? ANSYS Motion is a third-generation multi-body dynamics simulation tool. It's got some very clever solver technology, which enables complex contact, material flexibility, including plasticity, which can be included in the models and can solve some pretty impressive analysis. It's a complete software suite. It has preprocessor, post-processor, so that's setting up the model, reviewing the results of the model, and obviously the solver component as well. An integration with ANSYS Mechanical, which is the main product we sell at ANSYS for doing structural analysis, is coming very soon, starting with pre-processing. And within this tools, you'll be able to quickly and accurately analyze complex mechanical assemblies. There's a series of toolkits you can add on. There's a links one. Links is great for looking at chains, drive belts, continuous tracks that you might find on tanks and conveyors and things like that. A drivetrain toolkit, which is looking at gear trains, bearings, shafts, and complete systems like that. And then also there is a car toolkit, which includes specific enhancements or features for modeling vehicle suspension assemblies and modeling complete vehicle dynamics. And then also there's a module called EasyFlex, which allows you to have mesh-free flexible parts. So multi-body dynamics, MBD, is the study of dynamic systems, which can be pretty complex, which are a mixture of rigid and potentially flexible bodies. So they don't necessarily have to flex, but they could flex. You want to take that into account. They can interact with each other through a series of connections, such as joints, i.e. I'm going to say that this shaft has this wheel rotating about it, or coupled a pin. We can also look at constraints, so one thing moves a certain proportion to another thing, and also contact, which is what's going on here with these gear systems. So the teeth are actually touching each other, and that load transfer and flexibility of those gear teeth is taken into account to more accurately model this whole system. So multibody dynamics overcomes one of the main drawbacks of modeling just a pure rigid dynamic system, which that doesn't really consider the stresses induced in individual components while the system is in motion, and as a result imposes some kind of limitations on what you can do during the design side. Because you can't really look at what's going on with the system life, the plastic or elastic behavior of parts, and you can't take into account optimization of mass and that kind of thing. So being able to calculate all of these effects is very important. So this example here is a drive belt, the kind of thing you might find at the front of a car engine. There's a driving wheel and there's some wheels that are driven. And as the belt goes around, we're modeling the tension in that component of the drive belt as it goes around. And it's a very long transient run, which would be difficult in other solutions. So areas of application for MBD, multibody dynamics, run from heavy industry, like cranes and diggers, consumer products like printers, both kind of conventional ones and 3D additive ones, where we've got moving components on drive belts and control arms. Anything where you have a mechanism and are interested in the forces generated in the joints or the stresses in the individual parts. This could be complex gear train like you saw before, with the flexibility of the gears and the gear teeth and the bearings within the system. Or it could be a simpler case where parts are flexible and need to have these contacted with each other over a long time. Or, of course, full vehicle dynamics, as you can see here. So the example you see here is an excavator with some tracks, obviously with the tracks there. A customer in this case was interested in the behavior of the track when driving over some rough ground, of which we have our rough ground here is a flat road with some blocks on it. The toolkit used here was the Lynx one I mentioned earlier, and what was happening in real life was as the excavator was going over the rough ground, the track was actually coming off the driven wheels of the excavator. And if you can imagine when that happens, it sounds fairly straightforward. I just get some jacks underneath it, I lift it up and I reconnect things. Except when it's halfway down a hill, the hill's really muddy and it's raining and things, then it gets a bit more involved. So kind of avoiding that kind of scenario is pretty important on a piece of equipment which is near impossible to get to. So what the customer did was they used this product, carried out various simulations and calculated what's the driving forces required to move over the blocks and see the movement of the tracks as the wheels, with the wheels as these bumps were encountered. They were able to avoid this track shedding issue, and as a consequence, and understanding the behavior of what's going on with the tracks, extended the expected life from 2,000 hours to 8,000 hours. So it's a four times increase in life expectancy there. So what is particularly encouraging about this new product is that it's not actually new at all. It's been sold almost exclusively in Korea and Japan for the last 10 years, with pretty good acceptance and very good success. And the product is the baby of a guy called Professor Daesung Bae. And if there are any MBD experts in the room, I'm sure they will have heard of him. He's produced or been involved with the creation of several MBD products. And along the way, he's learned a lot about it. So this is third generation solution. The example we're looking at here is what's called a ball screw mechanism. It used to be used in steering systems. So you basically turn a screw shaft and it moves the driven part left and right like it would in the steering system. I don't think it's used very much anymore, but it's quite a complex system going on there. There's lots of contact between these spheres driving along this screw shaft. So Professor Daesung, as I mentioned before, he learned a lot about the different MBD codes along his way and has implemented everything he learned into this third generation product, Ansys Motion. And some of the things you can simulate in this tool are pretty incredible in my opinion. I never quite seem to get my own bike set quite right, and there's always a clicking when I'm either in the highest one or the lowest gear on the rear chain set. So maybe I should have a go at this tool myself as well, take my own advice. So the last thing I wanted to show you very quickly was the promised sneak peek. Unfortunately, it's a little bit Benny Hill style. This is actually quite an old build of this new interface. This is a new interface for Ansys Mechanical, which the pre-processing for Ansys Motion will be available in very soon. This is coming in Ansys 29 R2, which will be out in June this year. There's tons of capabilities in here, too many to list right now. A lot of things around customization, a lot of opportunities for scripting and automating workflows, and basically a huge leap forward in terms of productivity and ease of use within this environment. So this is showing a quick setup of an Ansys Motion model, showing a fairly simple CAM follower system. You'll get to see more of that soon. So, in the last 50 years, there's been pretty huge advance in dynamic analysis. So the stick model I showed you was used by a major aircraft manufacturer back in the mid-60s, early 50s, late 50s, early 60s, and has moved on quite considerably. So these full dynamic systems now of entire vehicles are pretty sophisticated indeed. So I think you'll agree we've come a long way. I'm always excited to see what customers do with our technology, and particularly with this one, as the animations are pretty cool. So let's see what happens. So thank you very much for your attention, and thank you. Hope you have an enjoyable day.